Hello, welcome to our live teleseminar with Dr. Elaine Ingham, and we're excited to get going. There are so many questions and so many people who've joined the call. But first, a quick outline of how the call will go today. My name is Helen Disler and I'm your host for today's call. Right now, all your lines are muted as Dr. Elaine Ingham will be invited to tell us what her message is for you all. She'll introduce herself and then tell us who she is and why she's passionate about people understanding the importance of the soil food web. So welcome, Dr. Elaine Ingham.
Hi. So I'm Dr. Elaine Ingham. We do a lot of work in organic agriculture, really trying to look at the cutting edge of what do we need to further the understanding of organic agriculture. How do we get away from using pesticides and the inorganic fertilizers? What is it? What are the easiest ways? What are the management practices that we need to do to be able to farm, with whether at a small scale, backyard garden, window box, or slightly larger, quarter acre, half acre, and on up to some of the largest farms on the planet, where we're looking at 50,000 hectares or more in some cases. So what are the management practices that get us away from the toxic chemicals, reduce the work, reduce the damage to the environmental system? There is a lot of hope that we actually can do this. We can return the soil to a condition of health. It's not going to cost millions for us to do that. It's not even going to cost hundreds of thousands of dollars. It's not going to take years to achieve this goal. We can get there within one growing season. As soon as you get started and you really understand and grasp what each of the different organism groups do for you, and then make certain that you have those organisms functioning, performing their jobs in your soil, all of the benefits of having this improved soil food web can indeed be yours. So we're talking about getting rid of disease problems and pest problems. If you've got the biology right, you don't have those problems. We're going to increase yields typically, but that's because of a consequence of improving the biology in your soil, getting the soil structure built so water and oxygen move into your soil easily and rapidly, but is held. You have that water holding capacity. You've got fully oxygenated systems. Your roots will then grow as deep as they possibly can. And it requires all of the food web. And so many people get stuck on just fungi, as if that's the only thing in the food web. And that's ridiculous. It's like saying, all I need is my brain, and I'll be a rich and happy person. Well, never mind that you can't do that if you don't have a body. So all of the parts of the system have to be working together, and then we can get all of these benefits. And of course, if you don't have to put on inorganic fertilizers, you don't have to put on pesticides, you don't have to do all of that work, your costs of growing your plants decrease. We typically see an increased yield, but because you're improving nutrient cycling in soil, you're improving water holding capacity, you're getting the roots growing as deep as they possibly can. And of course, if your plant is not stressed in any way, then the nutrient value of your food increases. Whatever you're producing is going to have a higher nutritional value because at no time through the growth of that plant was it stressed. So the bottom line is you've got to get the biology right, and you have to understand what your plant needs. Different plants require different balances of bacteria and fungi, and that influences and affects the form of the different nutrients. Different plants require different forms of nitrogen, for example. And so we've got to get an understanding of all of these parts of the food web. So it's really, Helen asked, why is it that I'm doing this with people? It's to make certain that we stop destroying the environment. To raise food for human beings does not require destruction of water quality. It always drives me crazy when Monsanto says, we've got to have engineered organisms, or a chemical company says, we've got to have all of these toxic chemicals being poured on our agricultural systems in order to grow enough food to feed all of the human beings on the planet. We already make more than enough food to feed everybody on the planet. Why are people starving to death? Because we're not really good at getting the food out to everybody who needs it. It's a political problem. It's not a requirement to have more genetically engineered or to throw on more toxic chemicals. We've got to stop destroying the environment. We've got to reverse global climate change. How do we get that CO2 back into the soil from whence it came? It's our agricultural practices that have been driving the organic matter out of the soil, ending up as elevated CO2 in the atmosphere. Yeah, gasoline and use of fossil fuels, that all contributes. But if we could start putting this organic matter, sequestering it back in the soil, in our agricultural systems, in our urban soils, in soil anywhere that's growing a plant, then we could reverse global climate change in a fairly short order. So getting this information out to everybody is really important to me. It's also important that I do something to correct some of the misinformation that is being related by people. I so often hear people say things, well, Elaine said, and I never said that. There's a lot of people out there misrepresenting what I say. And so when you hear somebody say something that's like, well, that doesn't sound like anything Elaine would have said on this during this course that Helen, that the Soil Center has been hosting. When you hear me, when you understand what I'm talking about, then you can help combat the misinformation that people are out there saying. So those are all of these many, many things that are reasons for why I'm doing this. So I think Helen's going to talk more about what's coming later after this question and answer session, but I'm really here to do this question and answer session for people. So how about if we get started with that? Is that all right, Helen, if we go on to that?
Yes, please do, Elaine. You've got the questions in front of you, and I know people are really keen to get some answers today, so go right ahead.
So I think I'll go through these. I think these are in the order that Helen got them. And so I'm just going to start through, and Helen, cut us off when it's time to finish up. Otherwise, I'll just keep going forever, probably.
Just a reminder, people can put their questions in while you're talking, Elaine.
Okay.
I doubt whether we're going to get to them, but we'll give it a go.
Yep. So the first question is, are there any dangers associated with overuse of actively aerated compost tea or the EM products of Dr. Higa? So let's take the actively aerated compost tea. Hopefully everybody knows what that is. It was discussed in the 3-day course. So we're talking about the situation where we've taken a really good compost, and you have to be looking at that compost to find out whether you've got those really beneficial organisms in that compost. We want to see really good bacteria. We want to see good fungi. We want to see good sets of protozoa, the flagellus amoebae. We don't want to see the ciliates. We want to see the bacterial-feeding nematodes, fungal-feeding nematodes, predatory nematodes. We don't want to be seeing any root feeders. And it's pretty easy for you to learn how to do this. It's not like we're trying to be massively quantitative with the simple, easy, direct microscope work that everybody can do. We're getting a pretty good idea of whether you've got these things in low numbers or pretty good numbers, or, wow, there's just all kinds of these good guys in my soil, or compost, or whatever it is that you're looking at. So with the actively aerated compost tea, we're extracting all of those good organisms out of the compost. So we got to use good water. We want to add a few foods, not a lot, because if you add too much food to that actively aerated compost tea, the microorganisms start growing so fast that they use up all the oxygen faster than you can aerate, faster than you can bubble oxygen back into that liquid. So you can't be putting too much in there. There's the danger. People have that attitude about, well, if 1 teaspoon's good, 25 teaspoons is better, and maybe 1,000 teaspoons would be best. No, you can't overdo. It is a case of the Goldilocks principle. Not too much, not too little. You want to add enough so you get the good microorganism growth. So when you spray it onto your plant surfaces, those organisms will stick. Active organisms make the glue, so they stick to those leaf surfaces, to the blossoms, to the seeds, to whatever surface you're spraying it onto. And I have never seen a situation where just a simple act of spraying these organisms out onto those foliar surfaces has caused any damage at all. The organisms are fed by the plant, so there are exudates coming out of the leaf, coming out of the stem, out of the petiole, out of the fruit, out of the blossoms. So these organisms, after they've used up the food in your compost tea, they've got to be fed by the plant in order to keep them active. If there's not enough food coming out of the plant surfaces, these organisms just go to sleep. Now, they'll still continue to protect your leaf surfaces from spores of disease-causing fungi or from aphids homing in on the plant surface, because you've covered that plant surface with these really good sets of microorganisms. So no danger in overusing an aerated compost tea, because it is the plant that's going to be feeding these organisms, and if the plant's not putting out the food, the organisms go to sleep. Now, sometimes people will ask, well, you just said you covered that whole leaf surface with these organisms. Isn't that going to block light from being able to get through to the leaf surfaces, and aren't you going to stop photosynthesis? And the answer there is no, because these organisms don't absorb those wavelengths of light that your plant needs for photosynthesis. They do not block those wavelengths of light, so there isn't a danger there either. So I've never seen any problem with too much aerated compost tea, or if we're doing a compost extract, and if you're going into soil, you would be using a compost extract. We don't need to activate and wake up the organism, have them making glues when you're going into a soil. So there's no need to make a compost tea if you're applying this out onto your soil surface, or to a solid surface of some kind where the organisms don't have to stick. So make an extract. You're not going to add foods. You just extract the organism straight out of your compost, and then you go out and apply it. You just want to test both your compost teas and your compost extracts and make certain that you have the organisms that you need to be adding into your soil. Or in the case of the foliar applications, you want to have the organisms so they will cover and grow and protect your plant above ground surfaces. So hopefully I've beaten that answer into the ground and you all know what the answer is. Now let's move on to EM products of Dr. Higa. And yeah, there can be some dangers associated with putting out too much effective microorganisms. That's what the EM stands for. And maybe we have to back up a little bit and understand what it was that Dr. Higa was doing and what his purpose in developing this product called effective microorganisms. So we've got to do a little history lesson here. I had to take a sip of water. So Dr. Higa was dealing with fungal diseases in root systems, particularly, and he noticed that when people took bokashi, or in different parts of Southeast Asia, these fermented materials where usually you take a salty water, you put your cabbage in there, you cover it, you bury it, and you let that ferment for a while, that fermented cabbage dish. You take the liqueur from that, and this is, my understanding is this is how we actually discovered this. He took the ferment, or he observed people taking that fermented liqueur, the liquid part, throwing it out on their fields, and noticed that in those fields they didn't have any problems with like clubroot or root-feeding nematodes or other fungal diseases of root systems, and started to question and try to figure out why this was working. And he noticed that the microorganisms in that fermented liqueur were very suppressive of the disease-causing fungi, the disease-causing nematodes, the root-feeding nematodes, and some of the other pests, and tried to figure out what was going on. And the lactobacillus, the actinobacteria, and some of the anaerobic yeasts that grow in that fermented liqueur can be very suppressive of some of the disease-causing organisms. So he started adding it into soils and found that relationship held true, so he developed that product, Effective Microorganisms. Now, I think he was very clear about the limitations of EM, but we've had people that learned from him, and maybe students of the students of the students of the students that started to hype that product and start to say that it would cure every disease known to man. It cures cancer, and it cures baldness, and it cures foot fungus, and it cures, oh boy, there is no product that can do that. There's a very specific mechanism for why EM works, and if you are in those conditions where you have a highly compacted soil, anaerobic conditions, and the root systems of your crops are suffering from those disease-causing organisms that grow in reduced oxygen conditions, then application of the EM product can help to build some structure under anaerobic conditions. They can knock out some of these disease-causing organisms if the EM organisms are in high enough concentrations. So typically you'll get the EM, the mother culture, you'll throw it into some water along with a little bit of plant material and let that ferment. You're maintaining the anaerobic organisms, these facultative anaerobes that are what make up that EM product. And so when you add those EM organisms into the soil, you gain those benefits. You start to build some structure. But these are only bacteria. They cannot, and the yeast, the fungal, the anaerobic fungi that are present, the yeasts, don't build structure at all. They are not responsible for that. So you get a little bit of building soil structure. You start getting oxygen moving back down into your soil. And, of course, that oxygen shuts down the EM organisms. You've got to have the aerobic organisms in your soil so that they can start growing. The aerobic organisms can do the full set of work that your plants require, where they will suppress the diseases, they will build all of the structure that you need, where they will start to cycle nutrients, so the whole set of benefits that occur because of the aerobic organisms in your soil can then occur. So it's a good intermediate step, but it is not the whole answer. So can you over-apply anaerobic organisms? Oh, yeah. You get too much lactobacillus growing and you can watch your pH drop, because lactobacillus produce organic acids, and the average pH on the organic acids that lactobacillus produce are somewhere around 3 to 3.5 pH. That is not a pH that you're going to be growing plants at. So, yeah, they have some fungicidal effects, but it's a step in the right direction, not the whole way you want to go. Okay, so hopefully I've finished with that one. On to the next. The question is, ideally, how much compost would you add per square yard, and to what depth would you mix it in? Compost with 21 times 10 to the 9th, or 21 billion bacteria per gram dry weight. Is 18 inches enough, or would 1-to-1 be better mixing into 36-inch depth? Okay, a couple things here that we got to think about. When you're thinking about adding compost into your soil, you really want to look at your soil first. What are you lacking? If your soil just has bacteria in it, and I'd be willing to bet you that unless you're dealing with an absolute toxic wasteland where there aren't any plants growing to begin with, if you've got any kind of plant growth in your soil, you got all the bacteria that you need. You're probably growing weeds, or that's what is being selected for if you've just got bacteria. So if your compost has just bacteria in it, it's not going to benefit you any. You maybe improve diversity some, but you have not put back in the nutrient cycling that is required. You have to have the fungi. The balance of fungi to bacteria is what determines the form of the inorganic soluble nutrients that are going to be released into that soil. If you've got a plant that requires ammonium, you better have fungal-dominated soil. So if you're dealing with a soil to begin with that just has bacteria, and your compost just has bacteria, you're not going to cheese. They're not going to be healthy. You're not going to be able to grow shrubs. You're probably not going to be able to grow tomatoes, or all of your plants are going to have problems unless what you're really trying to grow is weeds. Okay, they're doing great, but we've got to have the rest of the food web. Well, and it can't be just bacteria and fungi. We've got to have protozoa, because bacteria, when they grow, immobilize inside of their body all of the soluble nutrients. The bacteria and the fungi make the enzymes that will take your mineral nutrients out of the sand, out of your silt, out of your clay, out of your rocks, out of your pebbles, out of your organic matter, but they hold those nutrients that they've solubilized in their own biomass. They are just as not available to your plant as they are when they're sitting inside a rock, or they're sitting in your sand particle or in your clay particle. Bacteria take it out of the inorganic form. Now we've got an organic form of these nutrients, but they are not available to your plant. Same thing with fungi. They're pulling those nutrients out of the sand, the silt, the clay, the pebbles, the rocks, everything, but they're holding it in your fungi. Plants can't get it. They may be building some great structure, your root systems may be growing deeper, but in order to make the mineral nutrients available, you've got to have the protozoa that eat the bacteria. You've got to have the bacterial-feeding nematodes. You have to have the fungal-feeding nematodes to eat the fungi, the microarthropods to eat the fungi. You've got to have earthworms to eat the bacteria and the fungi. So you've got to have a predator in the system, because when the predators eat the bacteria or the fungi or both of them, then that's when plant-available nutrients are released. So you've got to have that whole food web. You can't have just bacteria in your compost. It's not enough. Now, when you're thinking about, I'm putting my compost out on my soil surface, can I just put the compost on the soil surface? Well, there's a couple things you got to pay attention to, a couple things you got to look at. Is your soil surface just like concrete? Then the answer to just putting your compost out on that surface of the concrete surface is you can't. It's not going to work. You've got to till. You've got to mix that compost into the soil, so you're getting it down to depth. If you've got a compaction layer down into your soil, try to till that compost deeper than the compacted layer. So go get a metal rod, push it into your soil, and see where it becomes difficult to push that metal rod through the soil. There's the compaction layer that you've got to till down to and get that compost in, so you start building structure. Of course, when you till, when you disturb and slice and dice and crush and smack together and grind your organisms between a rock and a hard place as you're tilling, you're killing a lot of the organisms that you want to have in your soil. So if you can get away without tilling, if your soil surface isn't like concrete, if there's nice good holes, if there's nice tilth in there, put the compost on the surface and then water those organisms in. Or gently rake, gently till it in. Don't go rototill it. That's, that's the, what is it on the tornado scale? The high is the F6. That's the F6 of tillage. You just practically wiped everything out. Plus anything that might have been in your soil got wiped out by that tillage event. So go in with a gentler tillage. Let's do a disc plowing, or even more gentle chisel plowing, or even more gentle moldboard plow, or even more gentle just a simple rake, a simple harrow. The gentler you can mix that compost back into your soil, the less destruction of the organisms in that compost or in your soil itself. So you got to be looking at what your soil is like, and then make sure that the compost has what's lacking in your soil. Look at your soil, look at your compost, and maybe you want to add some foods to help resuscitate these organisms once you till them in. It's just like human beings. After you've suffered a tornado, and if it didn't kill you, well, what do you then need in order to survive the experience? You need some food. You got to find some shelter somewhere. So just exactly the same for these microorganisms in your soils. If you can feed them a little bit of humic acid, if you can feed them some fulvic acids, something to help them recover as rapidly as possible and get going again, that would be great. So going on to the next one. How much rock dust, artesian well drilling dust, do you think ought to be added to composting as part of the pre-processing to ensure the microbes are not mineral starved? There is no way in God's green earth that your microorganisms are ever going to be mineral starved. As long as you've got sand, as long as you've got silt, as long as you've got clay in your soil, and it's not soil if you don't have those things, your microorganisms have all the mineral nutrition that they require available to them. They're going to have to be fed some foods. They've got to have an energy source, and that's where your roots come in. You want to have plants in the system so that the plant is putting out the exudates, the cakes and cookies, to feed those microorganisms. The bacteria and the fungi make the enzymes to solubilize any mineral nutrient that you require from your sand, from your silt, from your clay, from your organic matter, from the rocks, from the pebbles, from your bedrock. Everything is in your soil. There is no soil on this planet where a plant is growing that lacks the mineral nutrients to grow plants. So this whole concept of we have to be putting out these inorganic fertilizers, we got to put out rock dust, we got to put out lime, we got to put out gypsum, is just people trying to sell you a product that you don't need, because all the minerals that your organisms need are already in the mineral component of your soil. So we've got to get people off of that conception that your soil is lacking any mineral. Look at the total mineral concentration in your soil. Go read any basic soil science book that you wanna pick up. And if they talk about the total mineral nutrients that are present in any soil, you have hundreds of thousands of years of the calcium, magnesium, potassium, sodium, iron, even nitrogen is present in rock material. And what we're lacking in most of our dirt is the organisms to solubilize those mineral nutrients out and put it back into a plant available form. But remember, it's bacteria and fungi that do the solubilization, but those mineral nutrients are now tied up in organic forms inside the bacteria and fungi. Protozoa, nematodes, microarthropods, earthworms, all of our favorite predators in the soil eat the bacteria and fungi, and that's what releases those mineral nutrients in a plant available form. So stop with the rock dusts. It's not needed. So going on to the next one. Can we use forest mold to inoculate our crops? We always have to be careful when you're going out to any system. There could be disease-causing fungi. If you don't know that forest system really well, if you don't know it's healthy, then when you go out there, you could be picking up some disease-causing, fill in the blank. It could be disease-causing bacteria, fungi, protozoa, nematodes. You could be picking up some bad guys. So when you go and collect small amounts, please do not tear up the understory of our old-growth forests any worse than they're already being destroyed. So just small amounts, tiny, tiny little amounts is all you need to collect. And that goes into the compost pile at the beginning of the composting process. You don't want to use that forest soil to inoculate your crops, because what if you accidentally picked up some disease-causing organisms from that forest? You're now putting that down right around the root systems of your crops. Oops, maybe not such a good idea. So let's take that forest, that tiny bit of the good forest floor material, try to make sure it's as aerobic as possible, that is a good, healthy forest, but that small amount of material goes into your compost pile. So you have all the protection of the composting process to get rid of the human pathogens, the plant pathogens, the root-feeding nematodes, the weed seeds, and make sure that you're not sending any problem organisms into your agricultural fields, into your garden soil, let's not cause yourself any problems that you don't already have. So always put that samples from outside your system through the composting process. So when we're talking about the composting process, we can do composting through a thermal method, and so that high heat is going to be killing the weed seeds, killing the root-feeding nematodes, killing the human pathogens and the plant pathogens. But you got to monitor it. You got to make sure it stays aerobic the whole entire time. You could use worm composting. So we can have the worms come up and consume and pass through their digestive systems or touch the outside of their bodies, and all those wonderful microorganisms in there take out your disease-causing organisms, your plant pathogens, root-feeding nematodes, all of that. Now, worm compost doesn't take care of weed seeds, so you're going to have to thermal compost if there could be some weed seeds in there. The end of that question was also, what about species-specific relationships? Because we haven't really researched that part, which of the 75,000 species of bacteria that are present in this 1 teaspoon of soil, which are the best ones? Which are the ones that help your bananas grow best? Or which are the species that you need to grow strawberries? Or which are the species that we need to grow broccoli? We don't know that. There certainly are people in academic institutions that are beginning to look at that, so really trying to understand the different species of bacteria that are selected by strawberries. I think Joyce Loper is working on that, Oregon State University. But we're not at the point where we've really figured this out very well at all for any other plant species. So in the lack of knowledge, the best we can do right now is to maximize diversity in our composts. When we're extracting, getting those organisms into a liquid form in a compost extract or in a compost tea, we want to make sure we have maximum diversity. Start looking at all the sizes and shapes of the bacteria and all the different kinds of fungi. And we've got to maximize that diversity. We do not want to see just one kind of fungal hyphae. It drives me crazy when we have people in Australia, for example, where they strut around saying, I got more fungi than anybody else. But it's only one species. Good luck if you're not putting that species into this one exact habitat where it wins over everything else. So, for the 45 minutes every 2 years where the soil conditions are exactly right for that particular fungus to grow, your plants are going to be healthy and safe for that, few minutes. What about the rest of the year? What about, so we want to maximize diversity. So we have somebody living and growing and protecting your root systems, building structure, doing nutrient cycling every second of every day throughout the whole entire growing season. And if it's a perennial plant, you've got to have it functioning and growing. Somebody better be doing the job down in those root systems every second of every day throughout the whole entire year. So what are the number of species that you have to have in your soil, in your compost, to achieve that goal? Maximize diversity. Just do everything that you can to maximize diversity. So going on to the next one. How long do the microbes from compost tea stay in the soil? Well, forever. Until something kills them. They're going to be there forever. So, do you have predators? Do you have good structure built in the soil where your microorganisms can escape from their predators and have a safe site to live and grow, multiply, and then recolonize the soil from? We really want to have that kind of structure, so there is always a protected site for all of our microorganisms that they can escape from their predators. If your soil freezes, well, the organisms start to notice that it's getting really cold, and those that are not cold-loving bacteria or fungi or protozoa, they're going to form dormant stages. So if they can't tolerate that cold, if that temperature is getting outside their favored range, if it's getting too hot, if it's getting too cold, they're going to form a dormant stage, go to sleep. So they're still there, they're just in a dormant condition when temperatures warm up or if it's getting too hot and when the temperatures cool down, they'll come alive again and they'll start functioning again. So we haven't lost them. When your soil floods, as long as it doesn't go anaerobic, none of the organisms are going to be killed by a flooding condition. Lack of oxygen, yeah, you will start to kill organisms. If they don't have enough time to go dormant, if they don't have the time to go, wait a minute, I can't breathe, I better go dormant, they've got to have the time to notice these changes, react to them, go into a dormant stage. If the change is too fast, that's what kills them. If your soil is at nice, normal, ambient, 72 degrees or 22 degrees Celsius, if that temperature drops to freezing within 2 hours, okay, they all died because they didn't have the time to deal with that rapid change in temperature. If you go from normal temperatures to 2,000 degrees, well, they're all dead because they can't tolerate surviving. They don't have the time to go into dormant stages. So hopefully, once you put your microorganisms into your soil from a compost tea, would you have to inoculate the organisms over again? Well, if the conditions in your soil are so extreme, if you've got really no structure, you've got lots of salts, you've got lots of heavy metals, you've got all kinds of problems, anaerobic conditions, maybe those organisms in your first application of the compost tea did not survive because the change was too rapid. You had them growing in a really nice compost, you extracted them, and now they're in this really nice food-rich environment, plenty of water now, and now you go spray them out onto this soil surface that has a salt concentration that's like, whoa, and they just died because it was too rapid a change. They couldn't adjust to it. So you may have to go out and put on another application. You may have to go put on another application. How bad are the conditions in your, is it really soil? If you've got conditions that bad that it instantaneously kills the organisms when you spray them on. No, that's dirt. And so if you're playing with dirt, you may have to be inoculating again and again and again. And the example I like to use is to think about the colonists coming over from England to the United States. The first wave of colonists at Plymouth Rock, they landed, they started building houses, they started finding pasture for their animals, and then winter hit. And of the people from that first set of pilgrims that arrived, the first colonists, something like 95% of them died within the first year. So the first wave of colonization didn't work too well. But the second wave of colonists came over. And because the houses were already built, because there were places to stay, the animals were already there, they all survived a little bit better. So, only 50% of them died within that first year or two. Well, then the third wave of colonists came over, and look at, here we are, United States today. It took a few tries, but if we keep trying, we'll get it converted, and things will move along in the right direction. So the next one, do grapevines favor bacterial compost tea or fungal compost tea? Well, most of the grapevines that we've ever looked at require fungal dominance in the soil around their root systems. So grapevines require ammonium as their predominant form of nitrogen. They don't really do well on nitrate fertilizers. They really need ammonium, NH4, as the predominant form of soluble inorganic nitrogen. They take that up better, they can utilize it better, so they're going to be happier and healthier when they have more of their soluble inorganic nitrogen coming as NH4 instead of NO3. Therefore, your soil had better be fungal dominated. Grapevines like that slightly lower pH. The fungi will typically, the beneficial fungi, will buffer your pH between 5.5 and 7, which is precisely what grapevines need. Well, chicken and egg kind of question. Is the reason they like a pH between 5.5 and 7 because they need the fungal dominance? Or, so you can see where we can have some fun discussing those things, really kind of chicken and egg kind of question. So bacterial compost tea would be something that you might want to put onto the foliage because there we're trying to cover the leaf surfaces. Bacteria produce a lot more glue than most fungi do. So if you really want things to stick immediately and get that good coverage, that's where a bacterial compost tea might be applied when you're dealing with a vineyard situation. You got to get coverage, especially if you have aphids attacking, or if you have whiteflies, or if you have different fungal diseases. So think of all of the fungal problems, Phytophthora, mildew. Big problem with most grapevines in certain weather conditions during the growing season. So a bacterial compost tea is, if you apply that to the leaf surface, you're going to cover those leaf surfaces, and the spores of the mildew can't reach the plant surface. Now, think about when you want to be doing that protection. You want to get that protection on the plant surfaces before you have any green plant material growing in the springtime. So as you start to see bud swell happening, that is the time to get out with your first application of protection on those plant surfaces. And then typically about a month later, you would put on the second application. About a month later, you would put on the third application. And most of the time, we're well beyond the mildew stage of having problems. Can stop putting that compost tea out to protect the foliage. Typically in the second year, what we find is most of these microorganisms, the small microarthropods, the protozoa, the nematodes will climb up the trunk. They move out onto your leaf surfaces, and they will carry that really good inoculum from your soil. So you see why you have to get your soil back into shape. So getting those organisms back up onto your leaf surface, it can be carried by the organisms that will crawl up your trunk, or by the birds. When they land on your soil, they're getting this good biology. They land on your branches, and they're leaving the inoculum behind. A fly lands on your soil, goes up and lands on your leaf surface. They're inoculating really good biology onto those surfaces. So get your soil into shape, and typically in the second, or maybe it'll take until your third year, you won't have to be putting out the compost teas on the foliage anymore. Oh, but then how about your neighbors? Are they putting pesticides out on their property? Is it drifting onto your grapevines? Well, then you're going to have to go put a tea out. Because when they're pesticides, fungicides, do they work? Yes. They just wiped out all your beneficial fungi on your leaf surfaces. And now you're going to have to go reapply in order to maintain that protection so you don't have to use those pesticides and those toxic chemicals. So really, when you have drift from your neighbor's property, shouldn't they have to pay to put the biology back on your leaf surfaces, which their toxic chemicals destroyed? So where is our legal defense fund here? You need to get that developed, because it's ridiculous that we have to go back and fix something that they destroyed. They destroyed it, they should fix it. Going on to the next question. What happens to the soil biology when we cover beds with plastic mulch for growing strawberries? Does it become anaerobic because the air is effectively sealed out? Well, that's something you want to make sure you're not doing. Nice holes. So, think about where you're planting the strawberry plants in there. Make sure that the hole is not blocked, it's not held, the plastic's not held down in any way. So oxygen air is moving underneath that plastic sheeting. Make sure that you're not absolutely sealing the surface of that black plastic with soil along the edges. Leave some air vents, leave some holes. As you go through that growing season, the plastic's going to start getting beat up. It's going to start having holes, and the oxygen's getting back in there pretty well. We can have some heating effects. If you're putting down black plastic, you can basically be doing some solarization. And if the temperature gets really hot underneath that black plastic, the biology that's going to be lost first are the mycorrhizal fungi. And good luck growing strawberries without mycorrhizal fungi on the root systems. You're going to have diseases. You're going to have all kinds of insect pests. Your strawberries are going to be unhappy, unhealthy. So, the black plastic, make sure it doesn't get that hot under the black plastic, and make sure that there is good aeration through underneath that black plastic. It will go anaerobic if the air is sealed out, and then you don't see very good strawberry growth. Next question. What does the research say about the effects genetically modified plants on the soil food web? Where does the research stand at this time, and where is it going? With the genetically modified plants, we're dealing with really large companies that do not want anyone to allow any questioning of their genetically engineered plants. Notice that I am no longer a faculty member at Oregon State University. Why am I still not, or why am I not still there? It's because I had the temerity to point out to the world at a United Nations conference, a biosafety protocol conference, that genetically engineered organisms can be of a great deal of risk. The USDA and Animal and Plant Health Inspection Service, in their regulatory language, state that genetically engineered organisms are of no greater risk than the parent. And given that that's the regulatory language, they do not require testing, and so they can get away with putting out genetically engineered organisms that could be extremely dangerous. And what we're starting to see is that those genetically engineered organisms are very dangerous. When you start looking at animals who are fed genetically engineered plant material, so genetically engineered corn, or that are genetically engineered, those animals end up with terrible ulceration in their digestive systems. And in fact, most of this work had to be done in Australia, because here in the United States, you cannot get funding to do this kind of work. Because, gosh, who controls, we're getting political, so just think about the situation and who's controlling things. So the research is not being done in the United States. A lot of the rest of the world takes the view that all the best science is done in the United States because the United States has more money than anybody else. Okay, that's not true either, is it? So our research is stymied. We don't have the projects going on that we really need to have go on to demonstrate that, in fact, genetically engineered plant material is extremely damaging to animals who eat it. Well, if the animals, the pigs, the cows, other animals that eat that genetically modified plant material are having severe ulceration of the digestive system, their livers are being destroyed, what do the farmers call them? Irritable animals, and so put them down. Well, just think if your whole digestive system was turning into one big, huge, enormous ulcer, would you be irritable? So why won't this data be researched? Why won't this be done in the United States? Well, who's in control here? So that's the state of the research on genetically engineered or genetically modified plants. Certainly when we start looking at the food web, there were papers that were written back in 1990, 1992 by the U.S. EPA showing that genetically engineered corn caused massive changes in the fungal community in soil, that most of the beneficial fungi were destroyed, and the only fungi that were left were the disease-causing organisms. Dr. Don Huber published a paper showing what the effect of Roundup, and of course the use of Roundup has been massively enhanced because of the Roundup-ready plants, and he showed that when you apply Roundup, it causes your mineral, your soluble inorganic nutrients to be effectively disappear. What happens is the bacteria love to grow on the glyphosate. Glyphosate is a bacterial food. And so you put that on your soil, the bacteria eat the glyphosate, so very rapid growth rates. Well, when bacteria grow really rapidly, they have to have soluble inorganic nutrients, so they take them all up. And now what happens to your plant when there's no soluble inorganic nutrients and you don't have any protozoa and you don't have any good guy nematodes and you don't have any microarthropods and you don't have any earthworms? Well, good luck having any nutrition available to your plant. So the use of the Roundup has led to more use of the inorganic fertilizers. Who's making money? when we have these kinds of situations enhanced and ever more promoted. It's not the farmer, is it? So think about who's getting rich here, and you can start to explain some of this. So going on, how does one get back on right track with the soil after years of artificial fertilizers and chemicals? Well, the way to do it is to start making compost with plant material that has a huge diversity of these organisms growing on those leaf surfaces. So if you live in the middle of pesticide central, you're going to have to go out to some natural systems and try to collect small handfuls of materials, a few leaves, a few branches, some of that nice organic matter layer in a nice mature pasture or meadow. Go and collect the inocula. And then get your compost starting materials. You want some good alfalfa or peas or beans, a legume or manure, but try to get manure from animals that are not fed anything that's got toxic chemicals in it. So please, no antibiotics, no heavy metals. Stay away from, cow chow and other pelletized animal feeds because it has some pretty nasty preservatives in it. So your high nitrogen component, you want your green component. So anything that's green, anything that you mowed, that you collected while it was still green, there we go, good green component. And then you want the woody component. Anything that was standing dead. Or once you cut down a tree or a shrub or a bush and that woody material ages a little bit, chip it up. So sawdust, wood chips, paper, cardboard products, they're all good fungal foods. And so now if you want a good fungal pile, you're going to use mostly woody materials in your pile, a little bit of green, a little bit of high nitrogen, and then compost. Make sure it stays aerobic. Make sure you get high enough temperature. And so I think Helen is going to be talking about the whole course, and during that whole course I talk about how to make really good compost that has all of these sets of organisms in it. Gotta stay aerobic. So how do you get back on the right track? Compost. You can make it yourself. Do not go buy your compost from the municipal reduced waste facility. When we started realizing, or when the system as we are running it today, when those landfills started filling up, they decided that, well, we could take all the putrescible material and start putting it into large windrows and, just pile it up, let it sit there, reduce in size. And they realized that they could put a name on that and they could put a label on that calling it compost, and then people would buy it. Well, that's not compost. And don't even pretend for a second that that material is compost. If you don't believe me, take a look at that material through a microscope and you will discover that the only thing you've got in there are the anaerobic bacteria. You've got anaerobic protozoa. It's typically really bad news. Recompost it, put the right sets of organisms back in there, and then use it. So take the whole course, and we'll talk about that for quite a bit. Okay, on to the next question. What is the best brand of soil you can buy online? Highest in beneficial organisms, microorganisms, besides Denali Alaskan compost, which I mentioned in one of my seminars in California. Yeah, the Denali Gold or the Alaska Humus, that material that comes from Alaska, has some really fantastic fungi in it, typically. If you buy some of that, a little bit under the microscope, take a look. It should have just incredible strands of fungi, really big, wide, nice, dark brown, red, golden, tan, black in color, some really great fungi. So it's great for putting that fungal component back into the soil. It's great for the protozoa, getting that back, and usually some really good nematodes in there too. So you can see where that is some pretty incredible material. If you start looking, if you've got a microscope, you could start looking for compost in your local area that's got the organisms in it that you need. And then that would be your best choice of compost to buy to put these microorganisms back into the system. Soil Food Web in Oregon is another good place if you live in the western half of the United States to ask them Here's where I live. Are there any local composts? In Australia, Soil Food Web in Australia, Soil Food Web in New Zealand. So these various places around the world, to ask them, do they know people who are making really good composts? So let's see. Next, just wondering how long the course will be. We'll be able to view it offline and the cost. And Helen's going to cover that at the end of this session. And I haven't really talked with Helen about exactly how many hours and what the prices are that she's. So please address your questions to Helen about those things.
And Elaine, talking about that, our hour is nearly up, and I know that there's a heap more questions, and I'm afraid we're going to have to call it to a close. I know that you've got to take off very soon too. So the information that people have had their questions answered today, I know they will have had a very, very valuable response from you and people listening. Like it's very, very clear from your answers that there's quite a few things to know about this soil, and particularly the use of a microscope and the value of that. You teach all those things. You don't teach the microscope in the course, but you certainly do look at all the organisms and things that make up the soil food web and introduce people to those microbes. So, Elaine, unfortunately, we are going to have to close the call because we do want to quickly run through. We've got a special offer for people today. So, Elaine, I'm not quite sure how to close this except to say thank you very, very much. I love your work, and we're very excited to be part of the Soil Learning Centre bringing this course to folks. Is there anything you'd like to say on closing?
I'd like to thank you very much for putting in the time and the effort to give this information, put it out, make it available to people, and it's only because of you and the time that you've put to put it all together and offer it to people. I don't have the time. I don't have the staff to manage to do it myself, so it's absolutely fantastic. Thank you very much, Helen, for putting this time and effort into it, and I hope that those people who didn't get their questions answered, or maybe I answered part of the question that you wanted to know about, that you'll go ahead and sign up for the course. So more of this information, of course, lots more hours going over these kinds of things where I try to be slower, explain it all in very clear information. So I hope a lot of people will sign up for the course so they will get their questions answered.
Elaine, I'm sure they will, and thank you on behalf of everyone on the line that you've been here talking to us today. And I'm going to say goodbye, and for those of you who are there, please stay online. There's a button on the left of your screen that you can click to look at what Elaine is offering in her course. But in the meantime, Elaine, thank you.
Okay.
And we'll move on with looking at what the course is offering.
Yep, and I hope we can do this again. Of course, with
yes,
the course comes a couple more opportunities to have this kind of interaction.
Yes, and people online, please put your comments in now. You've got room to leave questions, but we've got some lovely comments coming through thanking you, Elaine, for your fantastic information. I can't believe they're getting this from you so readily. So please leave your comments, and please leave your comments what you'd like to hear next from Elaine. We may be able to arrange another one with you.
Yep.
So that would be an extra bonus for us.
Okay.
So thank you.
Thank you, and hope we will continue this in the future.
We certainly will. Thanks, Elaine.
Okay.
All right.
Take care. Bye-bye.
Thank you. Bye. Just looking now, if you click on that button on the left for the registration, it opens to a form which is actually telling you what the course offers. And it's got that lovely note from Elaine about there is hope and we can return the soil to health. But finishing with, you have to get the biology right for your plant, and you will if you get the whole food web back. And that's really the bottom line of this whole course, is actually understanding that whole food web and what you do need to do to get that balance. And maybe you've got bits of it, and maybe you understand bits of it, but then you get hiccups or you do something and it doesn't work. It's probably because there are gaps in your knowledge, and you really need to get educated with and find the knowledge of the Soil Food Web to truly bring your soil back to good working health. And you also have a guarantee. You can join the course for 30 days. If you discover it really isn't your cup of tea, you will be refunded. There'll be no questions asked, but you must do it in the first 30 days because it's very, very hard to know what a course is like till you take it up. So that is a genuine money-back guarantee, but we also expect you to genuinely participate. So we invite you to sign up today. If you know that Elaine's going to be able to help you to bring your farm back to full health, I say jump in. It's your opportunity to return your farm to health and profits and maybe reduce your stress and uncertainty that you're experiencing. And we can give you lots of examples of what others are achieving and provide them for you. So just email help@Soil Learning Centre to get your questions answered. And while you're here, just take a minute and calculate the cost of all the farm inputs, your fertilisers, pesticides, weedicides, drenches, water, extra feed. If they total over $997, which is what the full course will cost, and you are paying that year after year, then you need to do this course and stop the chemical roundabout, stop the inputs and return your health to your farm and to yourself, and even stop wasting your time. So I'll leave you to it, and just remember that, as Elaine says and makes it clear in a very fun way, that you must have the correct balance of biology to have a healthy soil. So thank you very, very much for joining the call, and we'll wait to hear from you. Thank you.